Welcome in, everybody. We're at the last part of the object-oriented programming. Right, we're at the end of week 14. So yeah, this is pretty much the last day of new material. Next week, we'll jump into some practice for the final. I think over the weekend, I'm going to release the practice final so folks can get a head start into it. But yeah, next week is going to be pretty chill. We're just going to maybe practice a few of the problems from the practice. Okay, today we're just going to finish up the lesson 20 on object-oriented programming and then move on to the lab. Right, there is a lab associated with this. It is kind of a short one, so we should be able to get it done in class today. And then finally, we'll give it a sneak peek into this next programming project. This next programming project is writing a class to represent a Wikipedia page. All right, so let's jump into it. We left off at lesson 20. We're almost done with it. So let me go to the lab, open up the lesson. Let me open up the last lesson. So number 20. Number 20, and then I'm gonna open up the lab as well, just because we're probably gonna finish this today. All right, so I got the lesson and lab open. Okay. All right. Now let's go to the lesson. We almost finished this. By the way, we're gonna go all the way down to over here. Where is it at? We're gonna end over here. This topic that says class design. But basically, this is optional. But yeah, we're gonna end at this last cell here, the blog entry. Okay. Anyways, we left off at this thing called a constructor, right? If a constructor is a member function, a member of the class that initializes attributes of the object. This means if I were to, run this cell right here, right? See, I just defined the class, and here let's go ahead and invoke this constructor. So this right here, let me clear this output. This was from a couple days ago. So here, let me comment this out. All right, this very first line is invoking the constructor. So I'm gonna play it. All right, we don't see any output, but something is happening. Right, see, so this right side, this is calling the init member function, right? The underscore init. So this is actually going up here and invoking this function, right? You don't have to worry about self. This is an implicit argument, right? We don't really see it, but this is the implicit argument that represents the object we called it with. So we'll talk more about on self in just a bit, but you might want to scroll up a bit to kind of visualize what self is. Scrolling up a bit, you'll see that self is like an implicit argument. It's not really inside of the parentheses when we invoke it. It's to the left of the period, right? It's the object that we use to call it. Okay, anyways, so we're invoking the constructor. It does do something, right? Just to prove it, I'm gonna go back to this constructor and then print. I'm just gonna print something like initializing attributes. Right? You don't have to do this. This is just a debugging statement to visualize the steps. Okay, so I'm gonna reload this cell, right? Replay it. So Control Enter. Okay, there it is. Just redefine the class. Now let me rerun this invocation. So boom, and yeah, see, it is initializing the attributes, right? It is calling this print statement, meaning that there are two brand new attributes being printed. Right. So once again, we're just kind of warming up a bit to this class we wrote a couple of days ago. There is another member function here called print stuff. This is, you can think of this as an accessor, right? Meaning that it's just going to let the caller C attributes. So all this is doing is dumping out data. If we were to call this member function, right, we would call it like here. Here, let me just delete all of this. So we would put the name of the object that we want to use. Right, the name of the object here is inst, for short for instance. Right, once again, you can call it whatever you want. Here, let me use a different name just because this is an okay name. Let me see. Let me call this. Um, I'll just call this me. Me equals simple, and then yeah. So I'm just gonna say me is equal to simple, and then me let me invoke this member function, right? So it's gonna be a me dot print stuff, right? So let's see, me dot print stuff, and then since this is a function, we need parentheses. Right? So I'm going to put parentheses after here. Right? If we don't put the parentheses, it's going to treat it like an attribute. Right? So it's a function. So I'm put this here. Right? Okay, let me rerun the function. So rerun. There it is. Right, initializing the attributes in the constructor, and then print stuff. Right? It says name is not available, and then job is not available. Right? This makes sense because we initialized it to these things over here. But yeah, once again, we're recapping stuff from a couple days ago, right? Me, this is the name of the object, right? It is an implicit argument to this function, right? So this me gets sent into this self argument, right? So it's kind of like this over here. This, yeah, it's a little different. Um, the point of this constructor was for kind of safety things, to make sure attributes exist before we access them. If we didn't have the constructor, let me delete this constructor. Let's see what happens. If I comment out this constructor, some dangerous stuff might happen. So I'm just going to comment it out, meaning that, let me rerun this. Okay, redefine the class, and then let me run this again. See, this first line is invoking a constructor, but it doesn't exist. Right? This doesn't exist. So nothing is really happening here. It's just defining me. Right? So if I were to print out the stuff, right, me.print stuff, let's see what happens. It's going to give us some attribute errors. It says this doesn't exist. So hopefully people kind of seeing the point of the constructor is to make sure that attributes exist so we can access them in the future. All right, let me bring this constructor back. Okay, there we go. So bring it back. Let me redefine the class. So press play. Boom. Again, go back down here, and no more attribute error, right? Because we made these exist. All right. Since these exist, we could probably initialize these attributes. I mean, we could probably define these attributes. There is another member function here called input name. You might remember from a couple of days ago. All this function does is ask the user to type something in. And when we type something in, it's going to override the attribute to whatever we typed in. So let me call the input name function. Me.input name. Okay, I'm calling the me.input name. It does take an additional argument. There is a argument here called prompt. This argument is a string that we're going to use to put into this input function. This input function kind of just gives a prompt, right? So if I were to put a prompt here like type in something, type in your name. This is just a prompt. Type in your name. This is going to get sent up into this prompt variable, and we're going to reuse it in this input function. So once again, all the input function is, it kind of waits for user input. So I just pressed play here. We're stuck inside of this function. We're stuck particularly in this input function. It's waiting for input. So I'm going to type something in like Andrew. And then the second I press enter, this input function will return a string. It's going to return the string that I typed in. I'll press enter here. Boom. Okay, I pressed enter. This finished. It returned Andrew. So the attribute got renamed to Andrew. All right. And yeah, we see that the job here got, the name got redefined. All right, hopefully people are cool with this so far. Okay. Set my projectors again. Every time I use this, it's only this classroom. Yeah, say what, Terrace? Yeah. Yeah, some reason this classroom has the glitchiest hardware. You know, it barely happens in that one for some reason. Yeah, okay. I'll turn one of them off. Oh, yeah. Let's see. Someone in the Zoom chat, let's see. Lisa, can people make sure they're muted, please? Oh, yeah. Yeah, let's see. Yeah, if feel free to mute yourself in case you're leaking any audio. Okay, anyways. Wait, what? What about the Wi-Fi? I'm using the Cabrillo's Wi-Fi right now, yeah. Oh, computer won't connect to Wi-Fi? Okay. Yeah, if you're having Wi-Fi issues, feel free to let me know. Hey, you know what? I'm gonna pause the recording here and check out your internet. Yeah, yeah. You just use a hotspot? Okay. Yeah. If you're at Cabrillo, you should be able to use secure HawkNet, but sometimes it's unstable. Okay, anyways, back to the material. So we just recapping this simple class. Right? All this class really does is it represents a person with a name and a job. I can do some more objects here. Let me create another object. Like, let me say someone else. I'll just call it someone else equals simple. So let me do this right here. Someone else equals simple. Let me play this. Right, so we're stuck in this first function here, me. Right, type in a name, Andrew, enter. Right, there we go. And then it printed out me, and then the job is not available because we never redefined that. But then in this last piece, we're invoking another constructor. We're creating another object from the class simple. I'm just going to do the same exact thing, like say someone else dot input name. Right, type in their name. This is just someone else, and then let me print out that someone else dot print stuff. Okay, let me rerun this now. So boom. Okay, this is printing. This is inputting name for me. I'll go Andrew. There we go. So this finished. It printed out my stuff, and then we're in this next someone else. I type in your name. I'll type in the name and say like Bob. Right, Bob, and press enter, and this member function finishes, and then we print out the stuff. Okay, cool. So all that we really did was declared two objects from the same exact class. Each of these objects are a different thing. Right? This is, once again, this is a cookie cutter. The cookie cutter defines how the object will work. The cookies here are just me and someone else, the actual object. All right, hopefully people are cool with this. The goal of this was just to kind of talk about the member function called init, short for initialize. Another word of saying it is constructor. In other languages, they'll call it constructor. In Python, they call it init. And yeah, this is just the same exact stuff we already covered. It's just yeah, we already covered this. So yeah, feel free to copy this over again. Same stuff. Okay, let's move on to something called a overloaded constructor. An overloaded constructor means that the initializer will take an additional argument. Our earlier class, over here in the beginning, the constructor only took this implicit self argument. But we can add in another one. Going down here, we can add another argument which will allow the caller to specify additional information. You might have seen this a couple days ago in our player class. A couple days ago, we brought up a scenario for an RPG game. Somewhere over here, let me bring it up. Sneak peeks, object-oriented programming. Yeah, a couple days ago, we did an RPG scenario, a role-playing game, and wrote a class named player. You might remember that the constructor took some additional arguments. These arguments allowed us to construct a player with custom attributes. Like down here we're invoking the constructor, right? And you see how the constructor has arguments, right? Typically they would be empty, right? This would be the default constructor, but when we put items in here, these are overloaded arguments, meaning that this two arguments will get placed into these two additional arguments. It's allowing the caller to construct with custom attributes, right? In this case, we're constructing with a string named Spider-Man and the health at 100, and we're constructing an enemy with different attributes. So yeah, let's kind of let's go back to this simple class, okay, in the lesson, and add in another argument that will allow the caller to specify a name. Okay, so let me go ahead and copy this over. Well, once again, this is, I'm gonna reuse the previous one. So let me scroll up. I'm just gonna reuse this previous one. Copy. And let me paste it here. Okay, we're gonna add in another argument here. In particular, I'm just gonna add in something called a initial name. Right, initial name. Okay. This means the user can type in a string, and we can use that string to override one of the initial attributes. So let me put it in here, right? I'll say that the self name gets initialized to whatever the caller requested. Okay, so let me rerun this. Okay, rerun this cell. There we go. Now I redefined the class, and if we were to call that function, right, this constructor member function, let me do it again. Right, let me go me is equal to simple. Right, so this is not going to work yet because I ran it. Right, we're attempting to call this constructor, but now it's saying we're missing an argument. This makes sense because we just updated the constructor to take in an additional argument, a name. So I could update this right here. This is the caller. The caller in this cell is calling the constructor. So let me put a name here. Andrew. There we go. And then I should be able to run it now. So I'll run it. There we go, right? No more error, right? Because Andrew, this string, got sent up into this additional argument, meaning that one of the attributes got updated. We could prove this by printing out the stuff. So let me print out the stuff. me.print stuff. And let me rerun this. Enter. There we go. So we initialize the attributes, and we didn't have to input name anymore. Remember earlier we had to invoke this member function. This member function was to allow the user to specify a name, but now we don't have to, right? The caller can just put it into this additional argument. So yeah, just another way of doing things. This is called an overloaded constructor. It's called overloaded because default constructors take no arguments, and the overloaded constructors take additional ones. All right, I hope you people are cool with this so far. Overloaded constructors. Once again, you can take a look at the RPG game from a couple days ago. This is pretty close to what we did too. In this case, we had 2 additional arguments, and we were able to invoke it like this right here, right? A name and an additional argument. Okay, yeah, this is some cool stuff right here. Yeah, the init member function. All right, and yeah, we can declare more objects. Like these 2 lines right here are declaring 2 more objects with the overloaded constructor. So let me play this cell. Right, there we go. We initialize 2 objects from the same class, but each of these objects have a different attribute, right? Like 1.print stuff, and then 2.print stuff. There we go. This is 1 and 2. Okay. Let's see. Let's move on to a tiny bit different one. A different type of class. This one's called a blog entry. This is the last type we'll see today. This is going to be kind of similar to the next assignment. The next assignment, the final one, will be creating a class called a Wikipedia, which will represent any Wikipedia page. So this class right here is called blog entry. It's kind of similar. All it's really doing is representing a object that has a title, author, and some text. All right, so let me run this. In this case, we have an overloaded constructor which only takes a title. So when we call the overloaded constructor here, see that this is invoking the init. It's invoking the init member function. Once again, a synonym for this is constructor. So I'll run this. There's no output here because we don't have any print statements. But we can go ahead and start visualizing things. Like let me go down here and maybe access their text. Right? Like let me say print b.title. Actually, b.print title. Okay, so print this, and yeah, it says first blog post. That's because we initialized this object with this title. We never initialized the author though. Right? You can do this later. Right? Like if we did b.author, right? This is none. And then same with the text. Right? This is also none because we never initialized these. So I would probably keep these to, you can initialize them manually if you want. Manually meaning that we're accessing like the author and then saying this is equal to Andrew, and then access the text goes to a hello world. Right? You can do this, but this is kind of manual work, right? This is manually overriding the attributes. So it's typically, you see, this is going to work. I'll run it, and we see that the attributes got updated. but this is kind of extra work. If anything, there's some better programming practices for this. Like earlier, you might have seen some functions, right? Like there was a function here called input name. This is kind of a better programming practice to override attributes because you can put in some protection. Like you could put in some if statements here. Like here, let me. But pretty much what I'm saying is you can put in some bounds checking, right? Like you could check if the name is too long, or you could check if the name is invalid. So that's why it's typically a better program practice to create something called set functions, right? Or you could put it in these these over here in the overloaded constructor, right? Because this is kind of the reason why this is dangerous is because we kind of have full power over overriding attributes, and you can put in some bad data. Right? But if we were to have like a function, right, like let me just make a member function that attempts to wrap this over here. Right? Like you could do something like set name. Right? Imagine if we had a function called set name that takes an argument called let's see, I'll call it name, or I'll say set author actually, set author, and then name is an argument. I'm attempting to write a member function which will give the user abilities to change the attributes without having to manually override it. So I'm just going to do the same thing here, right? Self.author equals name, meaning that this manual override can be rewritten to a b.setAuthor, b.setAuthor Andrew. Okay, so these two lines are doing the same exact thing, right? The first one is manually overriding the attribute, but the second one is asking the class to do it for us. See, so Andrew gets sent over to this name, and then the class will handle it for us. Right? The class will say, hey, set the self to name. Right? Self the author is B. So I'm going to delete this right here, this manual override. Okay, so there we go. And then run it, and there we go, right? It set our author correctly. This member function is a little safer because we can add in some protection. Like maybe we could protect from names that are too long. Right? Or I'm just making some stuff up, right? Like let's just say an invalid name is if the length of the name is too long, right? Or let's just say if the length of the name is too short. Right? Let's just say if the length of the name is equal to 0, then we can just put like not available, right? Like a self.author equals not available, and wrap this in an else statement. So this member function now has protection. Right? It's protecting us from empty names. If I were to manually, if I were to set it equal to nothing, right? Set author nothing, we should enter in this first protective branch, and it's going to set it to not available. So there we go. See how it says NA, right? Because we put an empty string here, meaning the length is 0, and the member function protected us from it, right? It protected us from empty names. It just put an NA here. Okay, so this is called a set function. This is like a set member function. Or actually, here, let me put this up here. This is a set. I'll give it a doc string. A set member function. All it does is changes the name attribute. Okay, cool. And here we're invoking the member function, right? We're invoking the set member function, which changes the name attributes. Okay, let me just put Andrew back in here. So put Andrew back in here, meaning that it should go into this function and then use this else branch because the length of the name is not 0. Okay, so I'll press enter. There we go. Okay. So once again, this is just another class called blog entry. It's kind of similar to our Wikipedia class. All this class does is represent, title, author, and text. But on the Wikipedia assignment, it's going to ask us to represent the summary. All right. Hopefully, people are cool with this so far. Okay, so that's about it for this lesson. We're going to move on to the lab. The next part of the lesson is totally optional. Everything underneath class design. Class design, it's going to talk about something called inheritance. Right? Inheritance is just an advanced concept where you're writing other classes that depend on a parent class. Like you could think of it as maybe you're writing a class called animal, and then underneath that class, maybe you're writing another class called cat, or another class called dog. In that case, the cat and dog would rely on a previous class. So that's where inheritance comes into play. And yeah, they're gonna use some of this in the next class. If folks are going on to the CS, I think it's called 20P. But yeah, for this class, we're not going to use too much inheritance. So yeah, this is optional. The class design. Okay, yeah, we're done with the lesson. Let's move on to the lab, and then after that, we'll go into sneak peeks for the last programming project. Okay, let me open up the lab. Oh, I already have it here. Okay, here it is. This is the last one. Okay, let's see. I hope folks get started on this, and then we'll give it like 10 or 15 minutes for folks to work on it. The first two are just the quick warm-up, and then the last two, 3 and 4, is writing a counting class. So we'll do this in a bit. Here, let me help folks get started on the first two. If you're on the recording, feel free to pause it and try it out yourself. I'm going to go over it right now, though. But yeah, these first two are just going to, it's pretty much like the beginning of the lesson, right? Remember the beginning of the lesson at the very top? At the very top, we created a class called simple, and it started off with nothing, just a pure doc string. And then we ended up getting an instance of this object. Now, this is at the very top of the lesson. And that's really what the lab is asking us to do. Right? It's asking us to create a very simple class called myClass that has no attributes nor functions. Okay, yeah, so once again, feel free, if you're on the recording, pause it and try it out yourself. It'll be good practice. Yeah, so write a class name, myClass. Right, so class, myClass, and no functions. Right, so let me put a thing here. And let me just put a doc string as well. Okay, this is just a simple class with no functions nor attributes. Just a quick warm-up to make sure folks are okay with the syntax. Right, once again, the syntax is just this right here, class, and then the name, and a colon. Right, there we go, and press enter, we're done. The second one is asking us to use this cookie cutter and create a cookie from it. Right, that's the difference between objects and classes. Right, instance, another word for instance is object. for a cookie. Right? Create a cookie from this cookie cutter. So you might see that in the previous one, in the previous lesson. Here's how we get an instance of an object. So we can do the same thing. Here is asking us to call the object instance. So I'll call it instance and then set it equal to the class. Right? The class name is called my class. And we do need these two parentheses here so we can call a default constructor. Right? Even though the default constructor doesn't exist, right, it is kind of hidden. It just doesn't do anything. So there we go, make an instance. All right, so this is just the warm-up. The next two are a little harder. They're asking us to write a class that represents something called a counter. Let's see, so here, let me pull up a visual for this. It's kind of like a counter tally. Let's see. Oh, it's kind of like this right here. For folks who might have seen this type of device, imagine we're writing a class that represents a tally counter, right? Meaning that we can create multiple tally counters. In this case, we're just going to create something called counter that keeps track of a number. And we're going to implement a couple member functions, right? One member function to increment the number, another function to decrement the number, and another function to display the number. So that's what we're going to do, right? Three main member functions. And that's what the lab is asking us to do. Right? Write a class named counter, and it's going to have one attribute. Right? In this case, we're just going to have an attribute that represents count. Right? Count is the number that's on the display. Right? So count is, in this case, the count is 0. It's also asking us to create a few more member functions, like, for example, one called +1. Right? +1, this is a member function that represents the plus button. It's representing this plus button right here. And then the opposite, -1. This is we're pressing the red button to subtract 1 from the count. And then finally, another member function that displays the value of the count. Okay. So let me help folks get started on this, and then I'll let folks do the +1 and the -1. I'll help folks get started on the constructor, this initializer member function. And I'll also help folks get started on this print count function, which displays the count. Okay. And okay, so here let's do it. So write a class called counter. Okay, I'll do that right now. So class counter, and this is, let me do a docstring here. Represents a tally counter that can increment and decrement. Okay. I'm going to do things a little out of order. I'm going to start off with this display member function. Now, once again, we're asking for 4 member functions. I'm going to do this last one first, and then do the constructor in just a bit. So I'm going to go ahead and define a function called print count. So make sure you get your indents right here too. So I'll define a print count function. And we do need a self argument here, because this is the implicit argument that refers to the object we're calling it with. Okay, for now, I'm just going to have it print out a certain number. Right? So in this case, we're In this case, the function should just print the value of the count. It's going to print out the current attribute. And the attribute here is represented as this number here. Right? See, this class should have the following member variables: count. This means that we should be able to do something called like a self.count. So do a self.count here. This is a member attribute. Okay, let me run this real quick. Okay, there we go. I defined the class. It has one function called that just displays the current count. Let's go ahead and test it real quick. Test the class by creating an instance of it and using all member functions. It's a good idea to test very frequently. So before we implement all of these member functions, right, let's test it one at a time. So I'm gonna do this one first and let's test it. So I'll make another cell here. We need to create an instance of it. I see, once again, this is just a cookie cutter. We need to create an instance for it. So the way we do that is name the object, right? I'll call it tally, right? And then we're setting it equal to the counter with these two parentheses. Okay, so once again, this is creating an instance of counter. Okay, let me make sure this works. So I'll run it. Okay, cool. We successfully created an instance of counter. Let me test the member functions that we have so far, right? Just this print count. So I'll go tally.print count. Okay, and it doesn't need any arguments here, right? Because tally gets sent up implicitly into the self. And we're going to attempt to print that tally's count. Okay, so let me test it. And we get an error here, attribute error. It's saying, oh, counter object has no attribute count. Right, this makes sense because we never initialized a count attribute, and we're attempting to access it here. So hopefully people might see what we need next. We might need the constructor next. Remember, the goal of the constructor is to set initial attributes. Like this initial member function. In this case, all we really need to do is set the count to 0. So let me go ahead and define this member function. Right, it's underscore underscore init. Let me define a function. Just 2 underscores. Init another 2 underscores. It's got a self argument in here. Once again, the self is representing the object we're calling it with. So this self would refer to tally here. Okay. The goal of this constructor is to initialize member attributes. The only member attribute we have is a count. So let's go ahead and initialize that count. So it is a self.count. And we should probably initialize it to 0. Right? This is like saying when we spawn a tally, what should the attributes be initialized to? In this case, we'll just initialize it to 0 because that makes sense. Okay, cool. Let me rerun this over here. So rerun. Okay, I've just redefined the counter, and let's test this now. So let's test this. Hopefully it prints 0. So run. There we go. Prints 0. So yeah, we just successfully defined a constructor, and our display function is proving that. So here, let me put in some. You don't have to put doc strings in here, but on the final exam, it will ask for doc strings. So let me document this. This is just a display function that shows the current count. And this is just a constructor that initializes attributes. initializes the count attribute. Okay, that should be a good start. There requires two more functions here. A function that represents pressing the plus button. Right? So let's say we spawn a tally, it's displaying 0. And if we were to say increment, right, or press the plus button and press the minus button, right, it should change the counter. Right? So this is saying, right, see there's two more member functions we need to do here, +1 and -1. This means if I were to invoke that function, which doesn't exist, right, if I were to say tally +1, right, and let me just spam this more, right? Let me just say +1. So assuming we have this member function, right, what should this print count print? It should print 3 instead, right? Because we spawn a tally that starts at 0, and then we're pressing the plus button 3 times, right? So it should print 3. Okay, so yeah, let's see if we can get this done. If anything, you need to add in a couple more member functions here that will modify this self count variable. Okay, yeah, let's give it like 10 or 15 minutes. Here, I hope folks get started on the +1. So define a function called +1. It takes a self argument, and I'll let folks to do this. Okay, so yeah, once again, +1 and then self. Right, self is tally. Whatever we call it with, this tally gets sent up into here. Okay, so yeah, let's give it 10, 15 minutes and see if folks can implement this incrementer and the decrementer. It's going to be very similar to our player class. Remember our player class? We did something like subtract from their health and have them heal. Let me see. A while ago, we did a player example, and we did kind of the same thing, right? Almost the same thing. Just the heal would increment their health, and then the take damage would decrement the health. So it's going to be very similar to that, but it's going to be a little easier. It's going to be a little easier because we're not really putting any additional arguments into here. We're just adding one at a time. All right, let's give it like 10, 15 minutes. Okay, let's go 10-minute timer. I might extend it if people have some debugging issues. Yeah, I can help you out with it. Let me pause the recording here. Okay, yeah, so you can get this done. To do, and then get the -1 as well. Okay, cool. Let's jump back in it. It looks like some people finished it now. Yeah, oh, what's up? Current function. Yeah, I did this one for you guys already. Yeah. Huh? Yeah. Yeah, okay, so someone in class was asking, what is this print count function doing? All it's doing is displaying our current count. It's kind of like just visualizing what the attributes are. So yeah, up here, print count just prints the current count value. Return? Yeah, these functions aren't really asking us to return something. Yes, typically functions do return something, but these ones are just modifying some inner attribute. Oh yeah, you're good. Okay, so here, let's get this +1 function ready. So we left off at this to do here. Right? Hopefully people figured out that you just need to add 1 to itself, right? Like set the self.count equal to the current count plus another one, self.count plus 1. Now, hopefully people got this. Let me define this, and we'll sanity check it. Right? Sanity check means we're going to test the function and print the result to make sure it's all good. So let me press play here, and yeah, it's printing 3. Right? So it looks like the plus 1 function is working. Right? And just test it more, right? Like if I were to do it more, right, 5 times, hopefully it does print 5. Yeah, it's printing 5, so yeah, we're good. Once again, this is equivalent of saying spawn a counter. So this is like saying, hey, spawn a counter, boom. Okay, and then we're gonna press the plus button 5 times. Right, so press it 5 times, and then visualize what's on the display. Right, so that's what we're doing here, right? We're pressing plus 5 times and visualizing the display. So yeah, we're all good here. The final one was to do something called the -1 function. This is just the complete opposite of plus 1. So it's the same thing, right? Define something called -1 in self. Right, once again, we put self because that's the name of the object that's being passed. And same thing, right? Self.count equals self.count -1. Okay, let me run this. Okay, cool. I just redefined the class counter. So make sure you run that cell. And let's test it. Right, let's do some sanity checks. So let me do some tally -1s. Tally.-1, right, and then tally.-1. There we go. We got 3. Right, this looks good. Right, 5 and then -2. Yeah, looks good. Okay, so yeah, hopefully people are kind of seeing what this is doing here. Right, this is really just we're spawning 1 tally. People might be wondering, oh, what's the point, right? All we really did was represent an integer in a very complicated way, right? Like, why is there so much code to represent 1 integer? Well, classes get more complex, and they can have more attributes. In this case, this is a very small one. Right? This class only has 1 attribute. But the big takeaway here with this cookie cutter is we can add more objects. We don't have to use 1 object named tally. Right? Like if I were to spawn another tally, right? Like let's say I did tally2 is equal to counter. And so I'll say tally2 is equal to counter. We're creating another object from this cookie cutter. So let me print out tally2 here. Right? At the bottom of the cell, let me go tally2.print count. Okay, so imagine you're kind of like spawning 2 tallies and we're pressing things at the same time. What do you think is going to print here? Whoops. 3 and 0. Yeah, 3 and 0 makes sense because tally2 never got incremented. Right? Like if you look at the top of the cell, tally2 starts at 0. Right? We're creating an instance. The self count is 0, and yeah, it's still 0. Right? But we can add in some more things. Right? Like if I just do a tally, let me do a tally2 dot -1. Right? Well, what should it print now? Right? It should print -1, right? Because we only modified tally2 once. The reason why we're representing an integer in such a fancy manner is because there's some sort of safety we can implement. Like, should we be able to get a -1? Right? Like let me say tally -1. Right? So let me just subtract a lot from the first tally. Okay, this might look a little hard to read, but all we really did was press buttons on both tallies. Right, let's see what it's going to print. They're both going to be negative. Right here, actually, let me simplify this a bit. Let me delete all of these over here. Let's just simplify it because this is getting a little hard to read. Okay, spawn 2 tallies. They start at 0. Right, what should happen if I start subtracting 1? Right, like let me say -1, tally dot -1. Right, and then tally2 dot -1. Now, what should happen? I see this makes sense, right? We took our first tally, subtracted 2, right? We took our second tally, subtracted 1, right? So it gives us -1. But should this be possible? Right? Like if you're given a normal counter, I think most counters stop at 0. Meaning if I were to press minus here, it's likely to not be negative. Right? It's likely just to stay at 0. So these can have some protection. Like this -1, we could possibly add in a branch that makes sure that the count doesn't reach negative. Right? Maybe we could put in an if statement. Like we could say if the self.count becomes negative, right? If it becomes negative, then, whoops, I'm typing in C++ right now. Okay, there we go. We could say if the count becomes negative, we can protect it by resetting it to 0. So I'll say self.count equals 0. Right, this is like a protection. So let me rerun this. Let me rerun this, and then test this again. Right? You see how they're all zeroed out now? Right? They're all zeroed out because when we tried subtracting from 0, the count became -1, and then the next branch protect us from that. Right? Saying, oh, we detected a negative, so just reset it to 0. So yeah, once again, that's kind of like with these counters, right? With normal counters, in my opinion, it should stay at 0 when you keep pressing minus. Okay. Here's another type of protection we can do, right? You don't have to do this, but let's just say we were to add more. Right, here, let me simplify this by keeping one single tally. So I'm just going to delete the second tally. I'm just going to keep this simple for now. Okay, let's say we have 0 as the first tally. Right, what do you think should happen if we increment it 10,000 times? Right, let's take this as a hypothetical example. Right, so you see how there's 4 digits here? Right, there's 4 possible digits. If we were to press the plus button 10,000 times, what should happen? Yeah. Yeah, maybe go all the way up to 9. What were you gonna say, George? Up to 10? Yeah, maybe. But I mean, if we were to take this hypothetical case, it would be impossible to get to 10,000 because there's only 4 digits here. So 9999. Hopefully people kind of see what I mean. This is a hypothetical example, right? So with our current implementation, if we were to add, let me go add 1, right? So let me add 1. I meant plus 1. Right, so if I were to do this 10,000 times, right, let me wrap this in a for loop that does it 10,000 times. Right, so once again, you can write range-based for loops. Right, I'm just going to say for I in range of 10,000. Right, so this for loop, once again, you got to go back to the previous lesson. It's just going to loop 10,000 times. We're not really using I. But yeah, let's test it. So I'm going to add 1 and it becomes 10,000. Right? Let me make it like 1,003. Right? And then press plus like 10,003 times. See, it gives us this number. Right? With this tally, right, if we were representing this should be impossible. It should probably stop at 9999, right? Or maybe with some implementations it'll go back to 0. Right? But let's just say it stops at 9999. We'd have to add in some protection, right, to the +1 function. Right? Like the +1 here, right? Maybe we could add in a condition, right? Checking if it's greater than some number. Right? We could say, okay, add 1 to it, and then maybe if the self count exceeds a number, right? Like if it exceeds 9999, right? Then we can set it back to self.count equals to 9999. And this is a protection. So let me press play on here. And yeah, if we add this many times, it's going to go all the way up to 9999. And so hopefully people kind of seeing what object-oriented programming lets us do. Right? It defines a class that allows the user to use objects safely. If we didn't have a class to represent this integer, it's possible to put impossible numbers in it. Okay, there is some equivalent ways of rewriting this logic. I'm not really a fan of this logic right here. It's kind of unsafe actually. I don't really like the order of it because we're kind of adding and then checking. It's probably a better programming practice to check before adding. So instead of doing this, I'm just going to check right here, right? Like maybe I'll revert the condition. Like if the self.count is less than 10,000, right? So we're saying if we're within the range, then add it to itself, right? And I'm not going to have an else statement here. You actually don't need an else statement, right? Because it's redundant. Right? The else do nothing. So let me try this right here. See, so it goes all the way to 10,000. I was off by 1. I need to make this right here less than 9999. Right? This is saying only increment when we're within this range. Okay, so let me test this. And there we go, right? We get 9999. Right? And you can increase the for loop, right? Like let's say we were to add 1 million. Right? This is saying press the plus button 1 million times. Oh, I was muted on the Zoom. My bad. Okay. Thank you, Lisa, for letting me know. Let's see. I was muted on the Zoom for the past 10 minutes. My bad. Okay. I wasn't muted on the recording, though. But yeah, for folks who are on the Zoom, all we're doing is adding protection to these member functions. Okay. Thank you, Lisa, for letting me know. Hopefully that wasn't too inconvenient. Just missed out on 10 minutes. Okay, so we added in some protection, meaning that if we were to press the +1 like 10,000 or 1 million times, it's going to just see how it's working. It takes a while, right? So we did it 1 million times, and yeah, it still stays at 9999. Okay, let's see. Yeah. Oh yeah. I'm not sure what you're talking about. Yeah. Huh. Oh, you probably have a syntax error. Here, let me take a look. Oh, it's not? Let me see. Oh, it's because it's print count. So it's pointing at your print count, and basically in these parentheses, this is a function. Yeah. So earlier in class, someone had an error here. I mean, not really an error, but if you don't have parentheses here, right here in the print count, it's not going to treat it as a function. It's going to treat it as an attribute instead, which is not really what we want. So if we got rid of this print count, the function, the parentheses, it's going to give us some weird thing here. It says bound counter is an object that this. Right? Pretty much this is not really a function call. It's kind of like a pointer that labels this function. So it's a little weird. It's not really calling it though. So let me put this over here. Okay, cool. Hope that makes sense so far. Okay. For the sake of this, I don't think we really need these protection. Right? I'm going to remove these protection just to keep things a little simple. But hopefully people kind of see the goal. Actually, yeah, I'll keep it in. My bad. And let me just change this logic here on -1. I'll just say if the self.count is greater than equal to 0, then subtract 1. Yeah. It's the same thing, same logic, just a little safer in my opinion. Yeah, I'll leave those there. Okay, let's see. Let's do the next one, and we'll move on to some Wikipedia classes. Okay, this next one, the final one, is asking us to update the counting class to have a overloaded constructor. Currently, our constructor takes no arguments. Right? It does take this implicit argument, the object instance, but let's write another one that takes an additional argument. This, once again, the point of an overloaded constructor is to kind of initialize custom attributes. Like you might remember from the player class a couple days ago. Right? A couple days ago, we had an overloaded constructor that allowed us to specify initial attributes. Meaning that if we were to spawn certain objects, right, we could put things in here. Right? So this is like saying with a counter, right? Here, let me create another cell. Right? Like let's say I were to create a tally and set it equal to counter, but I put in an additional argument at like 5. This is saying that we need to spawn a tally that starts at 5, right, for some reason. So hopefully people are kind of seeing the goal of this. Right, this is not going to give us what we want so far. It's going to say, oh, counter takes 1 positional argument, but 2 were given. Right, this is saying our current initializer, right, our current constructor doesn't support an additional argument. And that makes sense because our current one, right, only takes this self-implicit argument. So all we need to do is update this. Right here, let me copy and paste this. Let me copy this down here and paste it. Right, the goal is to update this counter class to implement that additional variable. Right, that's what it's saying here. We need to add in another variable called initial count that will use that as a custom attribute. So let me implement that here. Right, it's saying in our initializer, we need to add in another one called initial count. Right, initial count. And this is a custom attribute that will be used to initialize this counter. Right, so in the constructor, we can just say this equals initial count. Okay. So this is no longer a default constructor. It's called a overloaded constructor. Do we have to have it in a string? Oh yeah, this is a doc string. You don't have to have a doc string, but typically doc strings are good program practice because it lets the user understand how to use it. Yeah, the doc string is there so you can do something called a help, right? Like if I were to make another cell, right? I'd do like a help on the counter, right? It's gonna produce documentation. Right? So help, and it's gonna say, oh, here's how you use it, and yeah, classes are good stuff. I mean, doc strings. So just going on a little tangent because someone was asking about, do we really need these doc strings? You know, you don't really need it, but it's good practice because typically when you're writing code, it's for other people to use. Okay, cool. Anyways, we just implemented this initial count argument, meaning that this function should work now. Right? This is invoking. Once again, it's invoking the overloaded constructor. Okay, so let me run this. There we go. See, no more errors. So we properly invoked it. All right, let's test it. Let's make sure that our counter was successfully initialized. So I'll test it with the print function. Right? There is a print function called print count, and we're going to sanity check to make sure it prints 5. All right. Okay, cool. It printed 5. There we go. Let's keep testing. Right? You don't have to test it. I'll just go +1, +1. Right? This should print 6. Yeah, it's looking good. All right, and then this is 7. Cool. So this is spawning a tally that happens to start at 5 for some reason. Okay, it's happening to start at 5, and we're just adding 1 and then printing. Okay. Okay. Once again, this counter is really just a fancy way of representing a single number. It seems really annoying, but as our classes get more complex, this is safer. Okay, cool. Hopefully people are cool with this so far. All right, that's about it for the lab. Let's move on to the final project for this class. So I'm gonna quit these labs. Let me save it. Okay, I saved everything. Okay. Okay, the final project is right here, right? It's called Wikipedia Class. I already downloaded it onto my lab notebook, so let me just pull it up here. Okay, projects. Let's see. Wikipedia. Okay, this is the final project in the class. This is going to rely on a couple of previous lessons. In particular, make sure you're cool with data structures. A week ago, we went over this lesson here. So make sure you revisit this previous stuff. Data structures at the lesson 19. We're going to lesson 19. You might remember towards the very bottom of it, towards the very bottom of the lesson, we dealt with something called a web API. So I will take a look at the previous recording because we spent quite a bit of time working with the Wikipedia API. We were able to download data from Wikipedia that was stored in this certain notation. Right? This is, once again, it's like a nested dictionary. So yeah, feel free to take a look at last week's recording. But yeah, make sure you're comfortable with the last part of this notebook. The last part of this notebook is downloading data and kind of navigating through it. Right? Like here, this is a function that gives us ability to download information. And then down here, we're using that function to download it. Right, so here, I just played this, and then once again, I'm just gonna play down here, right? It says no summary because this doesn't exist. What we do rely in, it does exist. Okay, once again, this is data structures, lesson 19. This was from last week, so please revisit the last week, because our Wikipedia, our new homework will rely on that knowledge. All right, so going back to the project, our final project. The point of this project is to write a class that represents any Wikipedia article. There's a lot of things that are given to us. For example, there's this wiki fetch function. You might remember from last week that all this function does is lets us download data from Wikipedia. And it's going to return a JSON response, right, converted to a dictionary. It's pretty much saying you can put in any title, and then it'll return us a nested data structure. It's going to return us a dictionary that kind of looks like on the previous lesson, right, like this right here. Okay. So yeah, what's up, Terrace? Oh yeah, it's all good. Yeah, I don't. Yeah, feel free to leave whenever. Okay. Okay, let's jump into this project here. Right, there is quite a bit to look at here. All we really need to do is write a class that has a few functions. Right? In particular, all we really need is a constructor, right? An overloaded constructor, actually. And then a couple other member functions. One member function to tell whether or not a certain page exists, and another member function that will return the summary. Okay. There is a function called wikifetch that will download the data for us. So we're going to end up using this. Okay. The way this function works is it returns a nested dictionary. So I'm going to invoke the function here. All right, so press play. Okay. Oh, I forgot to press this over here. So let me define this function, wikifetch. There we go. And then this should work now. So I'll run this. Okay, so wikifetch, this function is saying, hey, Wikipedia, give me your representation for this page. Okay, so let me go back to the previous lesson, lesson 19. It's saying, hey, Wikipedia, give us some info. And it just happened to download this information right here. Right? This does look a little hard to read. Let me collapse all of this real quick. But it's like a nested dictionary, right? The outer dimension has 2 keys, and we can go into the second key and expand it. It's going to give us another dictionary, and this dictionary just has 1 key. Right, so I'll expand this over here, gives us another dictionary, and expand it over here, and finally the extract. So we had to dive down multiple layers just to kind of navigate this data structure. Okay, so let me go back here, Wikipedia class. So yeah, that's kind of what this is returning, right? This function is returning a dictionary. And we're going to end up writing a class that kind of makes it easier for the user to navigate this. Okay, I'll help folks get started on this. So let me put my name here. Okay, Andrew Tack. Okay. So we got to write a class called Wikipedia, like right here. Right? The name of the class should be Wikipedia. So let's do that right away. Let me scroll down. Okay. Oops, not here, my bad. Okay, we got to define a class called Wikipedia. So I'll say class Wikipedia. And then let me just put a docstring in here real quick. And once again, the whole goal of this assignment is to represent an article, represents a page. Wikipedia page. Okay, let me run this real quick. Okay, cool, I ran it. We have the bare minimal syntax. Okay, just so folks kind of understand what's happening here, and let me clear this output because it's kind of bloating my notebook. Clear. I want to make another cell here so folks kind of see the purpose of this class. This class is expecting a overloaded constructor, meaning that we can construct a class that has an additional argument. In this case, the additional argument is representing the title of the page to access. So let me attempt to call this initializer real quick. Let me attempt to construct it. So in a separate cell outside of this class, okay, I'm going to construct something like I'm going to call it query because we're technically creating a class that asks if something exists. So I'm going to call it query. Say query is equal to Wikipedia. Okay, and then it takes an additional argument. Right, once again, the additional argument represents the page we're trying to access. Like let's say we were on Wikipedia. Wikipedia. and then I were to type in something like California. All right, so type in California. Right, there we go. Where I'm gonna put California in here. Right, this is saying create an object from this class, and we're gonna try to access this California page. Okay, and this second argument is, let me scroll up a bit. I'm gonna scroll up and down a bunch. Hopefully people don't get too lost. Right? This second argument is attempting to access the title of the page. So let me go down. Let's see if it works. Now I'm gonna run this testing cell here. Okay, it doesn't exist. Right? It says, or no, it doesn't work. It says Wikipedia takes no arguments. This is because we never defined a constructor that takes an argument. So we need to define a constructor, right? It's define a constructor underscore underscore init 2 underscores, right? And then we need the self here. This is the implicit argument. And the additional argument is the page. Right? I think that's what we call it here, page. Let me scroll up to make sure we're all good. Yeah, so we're implementing this constructor here. Right? We got the two arguments, self and the page. All right. Cool. So let's make sure it works now. Okay, so let me rerun this class definition. Rerun, and oh, incomplete input. So it didn't even let me define the class. This is because our constructor doesn't have anything, and Python is telling us is expecting something in the body of the constructor. So let me just put something in here real quick. Like maybe we should store the title that they're trying to access. Like let me call it like self dot. Call it self. I'll call it self.title actually. Yeah, so self.title equals page. This is saying the class will store whatever they're trying to access, and it would be stored in a variable called title. Yeah, a string. So let me rerun this. Okay, cool, no more. And then let me rerun this bottom cell. Query is equal to Wikipedia. Okay, cool. No more errors. Meaning we successfully implemented our constructor, right? So the constructor is taking California and putting it into page, and this class is storing the title into here, right? Because you might end up using this later. Okay, let's see what else we need to do. Right? The goal of this class is to represent a Wikipedia page. In particular, it needs to have a couple functions. One function that will return whether or not something exists, right? And another function that returns the extract of the page. Right? The extract is the summary. Okay. Cool. Let's see. So you might have to look at the previous lesson for this in the previous lab. Like here in the previous lesson, we went on web APIs. You might have to revisit this and kind of see how to navigate down this here. But back to the project. Let me just attempt to call one of these functions real quick. Like, let's see, exists. Okay, I guess we could do exists first. This is probably one of the easier ones. Okay. Let's say we were to call this function, which does tell us whether or not it exists. Right? It returns a Boolean, true or false. So let me go down here. So query is equal to wikipedia.california, right? This is saying if we were to access the exists function, this should tell us whether or not this article exists. So let me print it. Okay, it should print true, right? Because Wikipedia California does exist, right? It's right here. Right? This query does exist. So let me press play here. Okay, see, it says this doesn't exist, or this function. Yeah, it's saying we never defined this function. But hopefully people kind of seeing what's happening. Let me clear this. This is kind of like saying if I were to type in like ASDF, right, just a bunch of random stuff, it should print false, because this probably doesn't exist. Let me see if it does exist. Right, so enter search. Okay, see, it doesn't exist. Right? No results matching the query. So yeah, this should print false. Right, but let's go to California. Okay, query.exists. Yeah, it doesn't exist. So let's go ahead and define this function. Right, we need to define a function. I'll call it exists. And let me put in a the self argument here. Right, there's only one argument required here, but let me just make sure. Yeah, the only argument we need is the self, which is the implicit object argument. Okay, let me just return a dummy variable for now. Let me just return like true for now. This is just a test to make sure things are working. Okay, let me make a doc string here real quick. So tells us whether or not the page exists. Okay, and once again, I'm just returning true for now. So this does print true, but it's hard-coded, right? Like if I did some random stuff here, right, it still prints true when it should print false. We need to update this function. Right? This function needs to be updated to kind of dive down a certain data structure. So I think I'm going to let folks do this on their own, because we actually already did this last week. You're just going to have to think about how to piece it together. Last week, we, on data structures, this lesson, towards the bottom, we worked on a way of testing if something exists. Like here, if I were to put in some garbage here, right, wiki fetch, this is a helper function, by the way. Okay, wiki function. Let me clear this output. Okay, so I'm gathering data. Let me look at the data real quick. Put this down here, actually. Move cell down. Let's see what this looks like. It is a dictionary. Right? It's a nested dictionary. And we can kind of tell whether or not things exist by diving down into the dictionary and seeing if this key exists. Right, so it doesn't exist. Right? The extract doesn't exist in this data structure, so it's going to print no summary. Right, but if we were to do something like California here, right, California, let's see what the data looks like now. Right, the data looks like this right here. Right? This is a nested dictionary again. And if you navigate through this data structure, right, like go into query, go into pages, go into here and here, now we see that the extract does exist as a key, right? Meaning that down here, this becomes true. Right? Extract does exist in this data structure, so it will print the whole extract instead. Okay. So yeah, you just got to kind of piece things together from the previous lesson. Let me clear these cell outputs. In particular, this Wikipedia class, right? This this exists, it needs to download data from the wiki fetch. There is a function here called wiki fetch, so you're going to be using this function. And pretty much this member function will probably download data, or you could download it in the constructor. Right? You could download it in the constructor if you want. You can download it in this exist function. It doesn't really matter too much, but either way, this needs to kind of look through some data and tell us whether or not the extract is a key in there. So I'll let folks do that because there's multiple ways we can do this. There's so many different ways. In particular, folks might be downloading here, right? Folks might be doing like a self.data equals wikifetch something, right? People might be doing this in here, right? Or people might be doing it down here. It's up to you, right? You can download it wherever. So that's downloading the data. Okay, and then finally, there is a function that we need. It's called extract. This one is just going to return the page extract. So let me scroll down. Right? Page extract just means the summary, meaning that if I were to access it, right, like let's say instead of printing the query.exists, right, let me just copy this. If I were to print the query.extract, it should probably print nothing. Here, let me see what it should print. Like if this was California or Lions, whatever, let me go California, right? It's going to give us an error. It should print out the summary from California. Right? It should download the data and then print all of this stuff out right here. Okay. If it doesn't exist, then I think you can just return nothing. Okay. Yeah, so you have to put some safety in this function. Or pretty much, there is a function here called extract. Right, I'll put a self argument here. Let me just return a dummy argument for now. I'll just return testing. All right, return testing, and this is the point of this function is to return the summary of a Wikipedia page. The Wikipedia page. Okay, returns a summary, returns testing. Okay, and then run here. Okay, it's going to print testing for now, right? Because you're going to have to update the function. Right? This extract is going to have to look through the data. Right? It's going to have to navigate through the nested data structure and grab the extract. Right? Well, once again, you can see that down here. Right? Down here, we were navigating down a bunch of nested dictionaries and then grab the extract in the end. So something like that. You might have to put in some safety here, like if we were to type in ASDF, right, what should it return? It's up to you. It should probably return nothing, in my opinion. Yeah, it's up to you. It should probably return nothing though. Okay. Cool. Hopefully this gives folks a good head start in this. All right. Once again, if this seems too weird, I mean, too complicated, you might have to go back to the previous lesson, data structures, and the lab too. Right? There was a lab here, 19. Towards the bottom of lab 19, if you successfully did all of these, right, right here, right, part 2. If you successfully did part 2 in the previous lab from last week, this should be a little smoother. Right? I think the hard part of this class is navigating through a data structure. So that's why I'm repeating myself where you should go back to the lesson in lab 19. Okay, but this should give folks a head start, right? Now you just got to fill in the blanks. You just got to fill in the blanks. This exists needs to navigate through the data structure and tells us whether or not the extract key is in there. And then this extract function needs to navigate down the data and then return the value from that extract key. Okay, hope that gives folks a good head start. We're about at the end of class now, so let's do some conclusions. We finished everything for this class. We got through all the material. Next week or this weekend actually, I'll release a practice final and folks should be able to get a head start on it. Next week, we'll probably go into a few sample problems, just a few of them, not the whole thing. And hopefully that gives folks a good preparation for the final exam. The final exam is scheduled for a certain day. It's a different day because finals week is different. Our finals week is different. Our final exam is on Friday at a different time. It's at 1 to 3:50 p.m. So there's going to be 3 hours to complete it. Okay. Thank you all for coming and hope you all have a good day.